Hello everyone. Let us start exercise 11A. First numerical. By imparting heat to a body, its temperature rises by 15 degrees Celsius. What is the corresponding rise in temperature on Kelvin scale? Relation between Kelvin and degree Celsius is K is equal to degree Celsius plus 273. Suppose the temperature of a body in degree Celsius is 0. So corresponding temperature on the Kelvin scale is 273. But now if the temperature of a body increases to 5 degrees Celsius, the corresponding temperature on the Kelvin scale becomes 278. Now if you notice a change in temperature on the degree Celsius is 5, and if you find the difference in temperature on the Kelvin scale, that also comes out to be 5 only. So whenever we mention temperature difference, whether we write its unit as degree Celsius or we write its unit as Kelvin, it will not affect the answer. Okay, so as long as there is a temperature difference, the temperature difference is same on Celsius as well as Kelvin scale. So here in our question, delta T is given 15 degrees Celsius. So delta T on Kelvin scale is also 15. Remember, you can write Kelvin in place of degree Celsius only if you are mentioning temperature difference. If you are writing individual temperatures, then you cannot write degree Celsius in place of Kelvin or Kelvin in place of degree Celsius. Second numerical. Calculate the heat capacity of a copper vessel of mass 150 gram if the specific heat capacity of copper is 410 joule per kg Kelvin. Now we know that heat capacity is either mass times specific heat capacity or Q upon delta T. Here we are given the information of mass and specific heat capacity. So we will go ahead with this formula. Heat capacity is mass times specific heat capacity. Mass is 150 gram. Specific heat capacity is 410 joule per kg Kelvin. So here first we must convert kilogram into gram. 150 into 410, 1 kilogram is 1000 gram. So this is gram into joule upon gram Kelvin, gram cancel, and the unit is joule per Kelvin. So 15 into 41 upon 10, and that is 61.5 joule per Kelvin. Part B. How much heat energy will be required to increase the temperature of the vessel in part A from 25 to 35 degrees Celsius? Heat energy required to increase or decrease the temperature is Q is equal to mc delta T, where m into C is heat capacity, that is what we just calculated, 61.5 joule per Kelvin. So let me substitute that value here, 61.5, and delta T is 10. So 615 joule is the heat energy required. Third numerical. A piece of iron of mass 2 kg has heat capacity of 966 joule per Kelvin. Find the heat energy needed to warm it by 15 degrees Celsius. So mass is 2 kg. Heat capacity, that is mass into C, is given. Okay, heat capacity is given 966 joule per Kelvin, and we want to find out heat energy needed to warm it by 15 degrees Celsius. So delta T is 15 degrees Celsius, or we can say 15 Kelvin. Heat energy required is mc delta T, massy delta T, mass 2 kg, specific heat capacity is not given, but mass into C is given. Alright, so we take 966 into 15, and that answer is 14490 joule. One four four nine zero joule is the heat energy required. Its specific heat capacity. So specific heat capacity is heat capacity upon mass. Heat capacity is 966 divided by mass. Mass is 2 kilogram. So this is 483 joule per kg Kelvin. Okay, since mass is given in kilogram, the unit of specific heat capacity becomes 483 joule per kg Kelvin. Fourth numerical. Calculate the amount of heat energy required to raise the temperature of 100 gram of copper from 20 to 70 degrees Celsius. Specific heat capacity is given. So amount of heat energy needed is mc delta T, okay, massy delta T. I call it as massy delta T. Mass 100 gram. Should we convert this into kilogram? Yes, we should. Why? Because specific heat capacity is given in joule per kg Kelvin. So 100 upon 1000, that is 0.1 kilogram. Specific heat capacity 390, and what is delta T? Delta T is 50, okay, 20 to 70, 50. So this is 1950 joule. Next, 1300 joule of heat energy is supplied to raise the temperature of 0.5 kg of lead from 20 to 40 degrees Celsius. Calculate the specific heat capacity of lead. Alright, specific heat capacity is Q upon M delta T, mass 1300 joule, sorry, Q is 1300 joule, mass is 0.5 kilogram, and delta T 20 to 40, 20. So that is 130 upon 0.5 into 2 is 130 joule per, mass was in kilograms, so kg degree Celsius, 130 joule per kg degree Celsius. Sixth, find the time taken by a 500 watt heater to raise the temperature of 50 kg of material of specific heat capacity 960 joule per kg Kelvin from 18 to 38 degrees Celsius. Assume that all the heat energy supplied by the heater is given to the material. Alright, so here heat energy required is massy delta T, but from where this heat energy comes? It comes from electric heater. So we can say here that electric heater converts what? Electric heater converts electrical energy to heat energy. Okay, electrical energy to heat energy. Electrical energy can be calculated using the formula power times T. At heat energy, massy delta T. So here PT is equal to massy delta T. Alright, power 500 watt, time we want to calculate is equal to mass, that is given 50 kilogram. Specific heat capacity is also given. Now this time specific heat capacity is given in joule per kg. Mass is also in kilogram. So no conversion is needed. And delta T is 18 to 38, that is 20 degrees Celsius is the temperature change. Okay. So T is equal to 50 into 960 into 20 upon 500. 50 cut, 960 into 2 is 960 into 2, 1920 seconds. And if I convert this 1920 second into minute, 1920 upon 60, that will give us 32 minutes. But you can keep the answer in seconds, that is absolutely fine. Seventh numerical. An electric heater of power 600 watt raises the temperature of 4 kg of liquid from 10 to 15 degrees Celsius in 100 seconds. Calculate the heat capacity of 4 kg of liquid and specific heat capacity of liquid. Now here power is given, heater is given, right, and we want to find out the heat capacity. So as we did in the previous numerical, we can use PT is equal to massy delta T, power is given 600 watt, time is given 100 seconds, and first we want to find out heat capacity, massy we want to find. So let us keep massy as it is, and delta T is 5, delta T is 5. So massy is equal to 600 into 100 upon 5 to 20, 12, 1, 2, 3 joule per Kelvin. 12,000 joule per Kelvin. Okay, that is massy, heat capacity. And what about specific heat capacity? So specific heat capacity, or C, is equal to massy upon M, right? Heat capacity upon mass. Heat capacity is 12000 upon mass 4 kilogram, that is 3000 joule per kg Kelvin. All right, 3000 joule per kg Kelvin is the specific heat capacity of this particular liquid.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.